Grace and peace to you all, and welcome to my channel. This is Donald Siame, author of A Hidden Mathematical Genius Within Revealed. Sketch and find the area or the region enclosed by the curves y is equal to cos x and y is equal to sin x, bounded by x is equal to 0 and x is equal to pi over 2. Okay, so today's question is on application of integration. Okay, so we need to sketch and find the area enclosed by the two curves y is equal to cos x and y is equal to sin x. In short, we need to sketch the curves y is equal to cos x and y is equal to sin x. A solution. Okay, so we're supposed to have our x-axis and our y-axis. So what we should know is that the maximum values for sine function and cos function is always 1. So the maximum for cos and sine is always 1. And the minimum value is always minus 1. Okay, so those are our values for y-axis. So in the x-axis, that's where we should have the angles now. So we have 0 degrees. Then we can have 90. That is pi over 2, and let's have 180, that is pi. Let's have 270, that is 3 over 2 pi, and 360, that is 2 pi. Okay, so we are starting with cos x. Y is equal to cos x. So always remember that cos x starts from 1. y1. Okay, what is cos of 0? Cos of 0 is 1. So our first point is on 1, that is 0, 1. Then cos of pi over 2, that is cos of 90, is 0. So that's our point, pi over 2, 0. Then cos of 90 is minus 1. So our point will be there. Then cos of 27, that is cos of 3 over 2 pi, is 0. Then cos of 360, that is 2 pi, is 1. So our sketch for cos x will look like this. It's just a sketch. Okay. Then for sine x, sine of 0 is just 0. So sine starts from the origin. Sine of pi over 2, that's sine of 90, is 1. So it will be there. Then sine of pi, that's sine of 180, that is 0. And sine of 270 is negative 1. Then sine of 360, that is 0. Okay, so our sine function will look like this. Okay, so these are the two curves. So we have this is the curve for sine, and this is the curve for cos. Okay, so we are told to sketch and find the area of the region enclosed by the curves y is equal to cos x and y is equal to sine x, bounded by x is equal to 0. So this is x is equal to 0, and x is equal to pi over 2. So this is x is equal to pi over 2. This is the line. So our region will be this one. Okay, so this is bounded by the two functions, and also this one. Okay, so this is the area which we need to calculate. Okay, so we are going to calculate this by integration. Okay, so if you look at this, we can say these are two shapes. There is this first shape and this one. So what we can do is, first we need to find the value of this angle here, so that we separate these two. Okay, now this angle here is on the intersection. This is the intersection for cos x and sine x. So it means this is the point where cos x is equal to sine x, and we know that when cos x is equal to sine x, then the angle should be 45 degrees. That is pi over 4. Sine pi over 4 is equal to cos pi over 4. So this angle here is pi over 4. Okay, so we have our two shapes, this one and this one. And the first one is going to have our limits from 0 to pi over 4. And the second one is going to have our limits from pi over 4 to pi over 2. Okay, so let's calculate now. Okay, so area is equal to, so we have the integral from 0 to pi over 4. That is for the first one. Now if you look at this area here, this area is bounded by two functions. We have this is the cosine function and the sine function. So since the cos function is on top, we'll say cos x, and the sine function is on the bottom, so it will be minus sine x. So it's cos x minus cos x, then with respect to x, then plus. Okay, the second area, the limits are from pi over 4 to pi over 2. So you say the integral from pi over 4 to pi over 2. Okay, so this one is bounded by two functions. The function which is on top here is sine function. So it's sine minus, this one is cosine, so sine minus cosine, so sine x minus cos x. So we have sine x minus cos x. So we integrate this with respect to x. Okay, so we'll say area is equal to, okay, so we integrate those functions. So what's the integral of cos x? The integral of cos x is just sine x. So we have sine x minus the integral of sine x. The integral of sine x is minus cos x. So we are going to have minus cos x. There's already a minus here, so minus multiplied by minus is positive. So we have plus cos x. And we have limits from 0 to pi over 4. Then plus the integral of sine x. The integral of sine x is minus cos x. So we have minus cos x. Minus cos x. Then the integral of cos x is just sine x. So minus sine x. Then we have limits from pi over 4 to pi over 2. Okay, so area is equal to, okay, so the first one, we have the first limit, pi over 4, you replace pi over 4 there, then minus, we are going to replace 0 there. So the first one will be sine pi over 4, that is sine 45, you get 1 over square root of 2. I'm sure you remember that from special angles. So sine pi over 4, you get 1 over square root of 2 plus cos pi over 4, it's the same value, 1 over square root of 2. Then minus, so now we replace with a 0 where there is x, so minus sine 0 is just 0 minus cos 0. Cos 0 is 1, so minus 1. Okay, plus we come this side. This is minus cos x minus sine x. So you first replace with pi over 2. So cos pi over 2, that is cos 90, is 0. So this is just 0. Then we have minus sine pi over 2, that is sine 90 is 1. Okay, so we are done with pi over 2. So replace with pi over 4. So we have minus, this is minus cos pi over 4. So pi over 4, that is cos 45. So cos 45 is 1 over square root of 2. Now there is a minus here and a minus, so we're going to have a plus. So plus 1 over square root of 2. Then minus, we have a minus, then minus. So this is minus sine x. Minus sine x, that is minus pi over 4. It is also going to be minus 1 over square root of 2. So this will be plus 1 over square root of 2. Okay, then we simplify this. So area is equal to 1 over 2, 1 over square root of 2 plus 1 over square root of 2. You get 2 over square root of 2. This is minus 0, 0 is nothing, so minus 1. Then we have plus, this is just 0. So plus multiplied by minus, so here we are going to have a minus 1. Then 1 over square root of 2 plus 1 over square root of 2. You get 2 over square root of 2. Okay, so area is equal to, so here you say 2 square root of 2 over square root of 2 plus 2 over square root of 2. You get so since we have same denominators, you can just add the numerators. So that is 4 over square root of 2. Then here is minus 1 and minus 1. Same signs we add and maintain the sign. So minus 1 minus 1, you get minus 2. Okay. Then we can simplify this. Since we have over square root of 2 here, we can multiply both the numerator and the denominator by square root of 2. So we're going to have 4 square root of 2 over square root of 2 multiplied by square root of 2, then minus 2 here. So we are going to have area is equal to 4 square root of 2 over square root of 2 multiplied by square root of 2 is just 2, then minus 2. Okay, so area is equal to 2 in 4, that is 2, then square root of 2 minus 2. So this is units squared. So this is the area bounded by the curves y is equal to cos x, y is equal to sin x, x is equal to 0, and x is equal to pi over 2. Okay, thank you so much for your time.